Okay, so actually before we download the material, you can start downloading the material for today. It is that today? Oh yeah, unemployment.xlsm. I'm going to get that downloading. But we are going to need also realize that the Fallen Angel project is due Wednesday evening. There's some trouble with the grader on this one. I think it's isolated to this project. Otherwise, I'm going to have to do some serious work to figure out why the projects are behaving this way. Remember that when you hit submit, if you get an error message, what are you going to do? You're going to hit end. Your workbook will probably be hidden. You'll choose view, unhide, and you'll just submit again. It should go through the second time. So end, unhide, and submit again. All right. And let's go ahead and take a look at this unemployment workbook. Today so the content for today is really understanding loops. We've played a little bit with loops just kind of out of necessity to do interesting stuff, but today we're going to learn all the details of the 3 different kinds of loops that we have in VBA. So let's just take a look at the data that we have here. It's just a list of data and FIPS code. FIPS code, that stands for something. Federal Information, I don't know what it is, but it's some federal code that we have for each of the 3,000 and some odd counties that we have in the nation. So when you're trying to get federal data for Sumter County, Alabama, they are number 111011119. So there we go. Now I've given you some code already in this workbook as well. So let me come to the code. And there's 2 modules. Let's take a look at module 1 first. So we've got 2 subprocedures here. One just says get data, and it's going to call this other subprocedure get county data. And then here's get county data, which really calls this one called create web query. So let's take a look at create web query. That's over here in this module called mod web query. And so it turns out I like the web query wizard so much that I thought I just want to be able to call this directly without having to record the code and do whatever. So I made a subprocedure that just gets the web query. So you can call it directly. It's kind of nice. Get web query. You give it a destination range. Where is it going to start? You want to put this in A5 of the current worksheet or whatever. You give it a URL, and there's some other optional things here that you can supply as well. And what it does is it just, well, the code's simple. It just makes a new query table, refreshes the query depending on how you've given the parameters, and then again, if you've told it to save the query or not, it will actually delete that query. So instead of making a web query, it uses the web query to bring the data in, and then it gets rid of the web query is the default path that it goes through. So I think it's kind of nice. We'll just go through the overhead of having that query just long enough to be able to get the data, and I can create it again the next time I want it. And so that's then the actual mechanism that we go through to be able to get this data. So here's the idea. The subprocedure import county data does something we haven't seen yet in class. And I think I told you long ago, just believe that you have to have those parentheses here, but here we're actually using those parentheses for the first time. It turns out that inside those parentheses, when I make a subprocedure, I can actually declare a variable. It's a special variable called the parameter, but what's neat about it is the way this variable gets its value, it's not given a value inside the code. This gets its value when I call the procedure. So here I'm calling the procedure. Oh, and I think in other examples, we've actually said call here, C-A-L-L, but you don't actually have to say call in front of it. If you just put the name of a subprocedure on a line by itself, it goes, oh, I must need to call that subprocedure. And then it passes this FIPS code to 20,063, and that value then gets received by this variable. There's never a line that says FIPS equals 20,063, but that's what happens because I'm calling the procedure, I'm sending it this value, and that then gets received into this variable here. So later, when I say I'm interested in doing something with the FIPS code, it's got whatever value was passed in, is the term, when the function was called. It's kind of slick. Okay, and so that's just kind of the background that we have here. We're not talking about getting data from the web today. It's just the background that we're using to play with loops. In fact, I'm going to go ahead and just run this one. I'm kind of glad that the government shutdown is over because this website was down last week while the government shutdown was on. You went to the website and just said, sorry, the government's closed, come back later. Well, small price to pay to have the government closed, I guess. I'm not sure. I could have come up with a different example. Okay, so I executed that. It called this, created a web query and so forth, and it made this sheet. It's not a very good name. It's called sheet 1. but here's the data. So it's going to give us unemployment data from 2008 to pretty current. I think it's going to go right to 2018. Yeah, November of 2018. We're less than 3 months back. Oh, but these are projected numbers. So we're going back to October, about a quarter of a year lag. So pretty nice. What's so special about County 20,063? Has anyone figured out why I used that one? It's Gov County. It's the county my family named me after. Who gets named after a county? I don't know. They didn't really name me after the county. It's a family name. Came into the family, though, when great-great-great-grandma Phelps was crossing the plains, and they stopped in Gov County, Kansas. There we go. Okay, so let's go on then to loops. I'm going to come back here into Module 1, and let's do, we've played with a do loop so far, but let's treat all the details of it. So sub do loop demo. Okay, so you remember the do loop. You start with the keyword do, you end with the keyword loop. Do just says, I'm the beginning of a loop. Loop says, go back to the beginning. I've just created what kind of loop? Well, it's a do loop, but it has a special, it's called an infinite loop or an endless loop. Yeah, I've given it no way to get out. You'll remember that the Visual Basic Interpreter is a very lonely interpreter, right? People open Excel up, and the interpreter says, maybe today's the day that someone's going to use me. They wait around all day and they close it, never having used VBA. You can imagine that. For years and years and years and years, the interpreter sits there and nobody ever uses it. And so finally, when you give it something to do, even if it's not much like this, it does, in fact, it's nothing. It's doing nothing over and over and over again. It's so excited that it won't pay attention if you're trying to get it. It won't listen to you telling it to stop. And so here's what we're going to do. Anytime we have a do loop, especially, we're going to put in the keyword do events. Do events just says to the interpreter, once time through each of this loop, just listen in case I'm trying to get your attention. So let's go ahead and just do something that we can see. So print debug.print now. That'll just give it the system, that'll just show you the time from the system clock. So I'm going to go ahead and run this. And it is printing the current time from the system clock often, multiple times a second, maybe hundreds of times a second. Maybe 50 times a second, I don't know. But fortunately, because I have that do events in there, when I come and hit the pause button, it'll stop right there. So it's just a good rule of thumb. Anytime you do a do event, the other events we're going to talk about, they have a natural way to prevent you from accidentally getting into an endless loop. The do loop, not so much. So it's just a good idea to put a do events there into the loop. But how do we normally want to get out of the loop? Well, we got to have some condition that we're looking at. So I guess I could loop until time became a certain time, but it might take a while to get there. So let's just do this. Let me dim row as maybe a long integer. And I'll start row off at 2. Row R, just R. R equals 2. And now instead of printing that, I'm going to print, we've got a worksheet over here called counties. And it's got the names of all these counties in it and all this information about counties. So, but we're going to look at something that I don't think we've looked at before. Let me zoom in here. Control plus. No, Windows plus. Okay, so when I look over here in my Object Explorer, I can see that I've got a sheet right here. I've got a sheet called Sheet 1, and it looks like it has two names, Sheet 1. One in parentheses, one just not in parentheses. But now I've got one in parentheses here that says counties, and one outside of parentheses that just says county. Inside parentheses is the name of the sheet as it appears on the tab. The one before the parentheses is what's called the code name of the worksheet. Now, it's not like it's got a code name, like it's a secret agent or something. It's the name you refer to that worksheet through your code in. You can refer to it directly by that name. Incidentally, the way that you set that code name is with that sheet selected, and then if I come down here to my properties window, the name here in parentheses, if I change that, I can type anything I want in there, type that and hit enter, that will change that code name. It's the direct name that I can refer to that sheet through code. So I'm going to print, and instead of having to say the collection of worksheets that has a particular name, I can just go for its code name, which is county. That's a reference to that worksheet. Dot cells, row number R, column number 1, dot value. And let's also print, bless you, my son, and let's also print column number 3. And while we're at it, let's print X as well. Now, I still haven't given myself a way out of this loop. But fortunately, I've got the do events, and so I'll be able to break into it. But this should just spool off all that data. Oh, not X, sorry. It's R that we're working with. Oh, but I forgot. I forgot to ever tell it to go to a different row. So what row is it looking at? It's looking at row 2. I said R is equal to 2, print row number R, and we're never going to get to the end. So I'm going to break into this one, and now just come in here and say R equals R plus 1. So each time through the loop, R starts at 2. I get to this statement. It's going to print the information dealing with row 2. R now is going to take on a new value. What's it going to be? Its old value plus 1. So after this line executes the first time, what's it going to be? R is going to equal 3. Yeah, it was 2. It takes its old value, adds 1 onto it, and puts it back into itself. And so now that should cause R to go up. So now, there we go. So now it'll take us a minute, well, probably just a bit less than a minute to get through the 3,000 count, 3,400 or so counties. But even once it gets through the data, I haven't given it a way out. It's going to keep on going until what? Till the second coming? Actually, we'll end long before the second coming. Well, no man knows when the second coming, but what's that? Yeah. Eventually, it's going to get to the very last row, and it's going to try to go past the last row, and that's going to cause an error, and that's what's going to stop it. That will take us, we wouldn't get there by the end of class, probably not even by the end of the day. So we better interrupt it again. And let's give ourselves a proper exit clause. So here, I'm going to exit until I've run out of data. So I'm going to use the until clause just to say loop until, and we've seen this before, so we're going to take a long time on it, until that value is equal to a 0-length string. Actually, let's look at it a different way, since we're trying to do something different. I think there's a function called isEmpty, I-S-E-M-P-T-Y. And a cell with no value in it is empty. The isEmpty is true. So let me just say question mark isEmpty. Is E-M-P-T-Y. And the cell I'm looking for is row number 500,000 or so, column number 1, dot value. And that's true. That is empty. But if I look at row number 50, column 1, that's false. Good. Yeah, so isEmpty is returning true or false based on whether there's actually something in there. So it's another way to tell if a cell is empty. So now I'm going to go ahead and set this back to, well, actually, why don't we start R off at 2,000 so we don't have to wait through everything. And I'll stop this and run it again. And so now that should, why does it keep showing true down here? It's because it's running in front of the true that was there already. So it didn't actually print that. That was from me printing before. So each time it got to the loop, it says, is it empty? Is this condition true? It doesn't say, is it empty? It says, does this condition evaluate to true? I can put any condition right here that evaluates to true or false. And as long as it's true, until it's true, it will empty. It will continue to execute. So in this case, as long as isEmpty is false, it'll continue to execute. It executes until it becomes true. There's an analogous one. I can say do while. And now, instead of this one, I'm going to do while. This is going to execute while it's true, while the value is greater than an empty string. So it turns out an empty string is the lowest string you could possibly have. If there's any characters in there, it's going to be greater than an empty string. So the differences between the until clause and the while clause is just a matter of true or false. Do you want this to execute while it's true? Then you use while. Do you want to execute until it's true? You use until. And so that should produce the same thing. Questions? Yeah. Oh, yeah, we're headed there. We'll do that next. So the question is, what if we put the clause up at the top, right? If I put the exit clause up here at the top on the do, this exit clause can go either here on the loop or it can go up here. It belongs either place. Unfortunately, you can't have it in both. It'd be nice to have one clause at the top, a different clause at the bottom. I don't think that's allowed. Let's try it. Yeah, you can only put it in one place. Pity, actually, but. So the question is, what's different about this? What do you think? It's different. Any thoughts on what it might be? Go ahead, Ruben. Yeah, that's exactly right. I'm going to repeat that for the video. And that is when you put the clause up here, then it checks it before it ever executes the code that's inside the loop. It comes in here and says, oh, there's a while clause. Check to see if this is true. And if that thing is, you know what, I'm just more comfortable with until. So until this equals. So I'm going to do this until it equals true. And it goes, oh, wait a minute, that's true already. And it immediately jumps to the loop. It will skip the loop altogether if I put the exit clause at the top. But if I put the exit clause at the bottom, then I am guaranteed one time through the loop. And that is the only difference. The temptation is to look at it and think it's going to execute one more time if I put it at the bottom than if I put it at the top. And that's only true on the condition if it the first time, right? So once it gets past the first time, it's identical. Because what's the next statement? Where does this go immediately after loop? Where does it go? Back to the do. And so if the clause is up here, it checks it immediately after. There's no other code that executes between the top and the bottom of the loop because it goes right back up to the top. So the temptation when you're just beginning is to think, I want this to execute one more time, I'll put the clause at the bottom then instead of putting it at the top. The only thing it determines is it guaranteed to run the code once? And this can be really handy because suppose I want to start at 1 instead of 2. I can get rid of the initialization for R altogether and just inside the loop increment it. Now what's going to happen the first time I bump into this line? Here I'm going to say R equals something. What's it going to equal? Yeah, it's a numeric variable. And so all numeric variables get initialized to 0. So I declare it and R immediately has a value of 0. And so after this line executes for the first time, what is R? Yeah, it's going to be 1. So if I want my loop to start off at 1, I don't even have to initialize the value before the loop, but inside the loop I can just say increment here, and now it'll go through working at 1. So this, we'll go ahead and run that, but that should behave just the same. You have to slow it down. You can slow it down on the video. Go back if you really want to see. It really did print 1 there the first time through. Go ahead. Can the do events go anywhere? And the answer is the do events can go anywhere. Well, it could be outside the loop too. All do events does, it says at this moment in the code, are you trying to get my attention? And by the way, it does other things too. It's like it says, listen, if there's some events that have happened that have said, I want you to update the screen at this point, but I've been too busy to get around to updating the screen, you can force it to update the screen with the do events as well. So there's some other things that do events does. But the main one that we're worried about is it's checking to see if I'm trying to break into that loop. The question is, when can you watch these videos? And the answer is almost always within 20 minutes of class being over. I post them right here on Learning Suite. So if you come to Learning Suite, there's a column here called Class Examples. And if we open one in the past, you'll see there's the link to the video, and there's the file to download. So you put both of these things right there. What's that? Oh, if someone's already watching the video, well, no, actually, because people get to this by they're finding me directly on YouTube as well. And so when they see this, they'll go, hey, how do I get access to that file? And I'll just ignore that comment. Because I make these videos for you. If someone else can watch them, that's great. But I'm not going to post the other files for them. Sorry, YouTube audience. All right. Anyway, there we go. So, yeah, so that's the do loop. What else is there about the do loop that we haven't covered? I'm thinking. There's one more thing. Go ahead. Oh, yeah, no, okay, so the question is, can I have two conditions here? And the answer is no, I get one condition, but it can be a complex condition. Or x is greater than 100. And so now, because I've got a complex condition here, if this is true, or if this is true, the whole thing. So which one's going to happen first if I run this? Yeah, it should. Oh, yeah, thank you. Yeah, x will never get bigger than 100 because I'm not even doing anything with x. Oh, and because I've got option explicit set here, so I'm going to go ahead and run it. Because I have the option explicit clause here, it's going to say, hey, buddy, I don't know what x is. You have not defined this variable. And so I'll change that to r, and it should be able to run. And so now we should hit 100 with r, well, 101 because r has to be greater than 100, and then we're out. And that the exit clause can be as complex as you please. I encourage you not to make it too complex because they're really hard to understand, but the interpreter doesn't care. Make the thing huge. There's one more way out of the loop. So far we talked about 3 ways. Well, or in how you count, maybe 4. You can loop until, loop while, at the top or the bottom. You can break into it so long as you have do events. But there's also another way out, and that's you could have an if clause. We haven't talked about if. This is in the chapter called conditional branching. We can say, I want some code to execute only if a condition is true. So I could say, if x equals 5. Thank you. If r equals 5. Maybe we should just change the whole thing back to x. If r equals 5, then exit do. And so I've got this clause that just says exit my do loop. And so that lets me jump out of it. And so now, this one gets evaluated every time through the loop. That one should let me out way before the other ones do. So I'll run this and let me out after 5. So that's the other main way to get out of the loop. There's one more way to get out of the loop. I'm not going to teach it to you because if I show that to you, you're going to go, oh, I could use that for other things too, and it's going to turn you into a bad programmer. Look, you're already bad enough without me teaching you some bad habits. So we'll learn some good habits, and then maybe later I'll tell you the one other way out of the loop. Go ahead. The question is, why don't I have to do end if on that if statement? And the answer is, because in this particular syntax, it doesn't require it. And we're going to talk about that when we get to the if statement. So yeah, we got a whole day on the if, and this is a special case. And it's because I'm only executing one statement. But we'll talk about that in detail when we get to that part. Okay, that's the do loop. I think that's it. I don't think anything else is going to strike me to talk to you about that, but I'm going to leave that there just in case. So let's move on to the next kind of loop. I don't think we've seen the next kind of loop yet. So let's make another sub-procedure, and I'm going to call this one the for loop demo. Okay, so it turns out that and if we're looking at this one, if we weren't trying to get out of this loop based on looking at this cell, we're just trying to go until r was greater than 100, we say in the world of programming, that is so common to have a loop that we want to loop while this variable goes across this range. I want this variable to change its value from 1 to 97, and I want to run the loop once for each value in that variable. I want to run this loop 97 times, and my control variable is going to be 1 the first time through the loop, 2 the second time through the loop, 3 the next time through the loop, and so forth. That is so common that we have a loop that's designed just for that. Let's take a look at it. So this one unlike the do loop, this one requires a numeric variable. We have to have a numeric variable to work with this loop. So I'm going to declare it right here. I'm going to call it x, so I don't have to fight my tendency to want to write x as the control variable. Dim x as any numeric type will work. I'm going to use integer. I'm going to use long, in case I want to go above 32,000 rows. Okay, so I have to have the variable. Now here's the structure of the loop. It's called the for loop. So for, and if we look down here, we're starting off, oh, I got rid of it. We were starting off by initializing our variable. Somewhere we do that same thing here. X equals 1. We are giving it the first value that it's going to have inside the loop. But I also specify the range that I want it to go across, 2, 10. Next. That's the structure of the loop. So this is the kind of the minimal for loop that I can make. I've got a control variable x. When I print this, debug.print x, it's going to print 1 the first time through the loop. So we're going to come down here, and we're going to go, great, we're declaring a variable x. It's going to start off with a value of 0. That doesn't matter to us, though, because as soon as we get here, we're going to change it. We're going to give x a value of 1. We're going to print x. That's going to print 1. We get to next, and something invisible happens. Next is going to add 1 onto x. There's no statement here that says x equals x plus 1. It's part of what next does. When I get to the next statement, it says add 1 onto x. It jumps up to here, and it says, hey, is x larger than my top boundary? And it goes, nope, it's only 2. It's going to stay in the loop. It's going to print 2. It's going to get to next, and next is going to change x to 3. It's going to come and check here, hey, is 3 larger than 10? Nope, stay in the loop. So this should print, that should print the should print 1 through 10. Let me get on that and execute it. There it is, 1 through 10. And it printed that single quote probably because I typed a single quote. Didn't really print that. Okay, questions? Go ahead. What happens if I put x equals x plus 1? I can still do it. X equals x plus 1. Let's think about it. X is going to start at 1. I'm going to print 1. I'm going to say x equals x plus 1. It is now 2. I hit next, and next says add 1 to x. That's going to make it 3. So this should just print the odd numbers. Let's run it and find out. Let's clear this off. Let's run this. 1, 3, 5, 7, 9. Yeah, don't ever do this. X equals x minus 1. What have I just done? An infinite loop. I'm going to say x goes 1 down, x goes 1 up, run it again. X goes 1 down, x goes 1 up, run it again. I don't even have a do events in here. I probably should put a do events in. Now, the truth is, I normally don't put a do events into this kind of loop because it's kind of hardwired. You got to really try to make a do loop. You can go into an endless loop easy without trying. You got to try to put this one into an endless loop, but it's still possible. We just did it. We didn't run it because I didn't want to have to lose all my code, but yeah, might be a good idea while you're starting to go ahead and throw a do events in here as well. Die events, die. Do events, yes. Doesn't hurt to have it there. Now, it turns out this idea of incrementing by something besides 1 is built into the idea of the for loop. I can do that right up here. So for x equals 1 to 10, step 1. If I say step 1, it's going to count by 1s. This is the default. If I don't say step anything, it's going to step by 1. And so we'll see it count by 1s. But if I come in here and say step 2, then now it's going to count by every other number. And of course, if I want the even numbers, what do? Just tell it to start at 2 instead of starting at 1. And now that'll give me the even numbers, 2 through 10. Questions? Go ahead. Oh, so the question is, so it doesn't have to end exactly at 10, anything above 10, that's exactly right. In fact, watch this. I'm going to send this back to step 1. And when we're done with the loop, I'm going to do another debug.print of x, but I'm going to give a label to this one. X is now, and then I will concatenate on x here. So I'm taking x from 2 to 10. And so if we go back and see, there's the 2 that it started with, 2, 3, 4, 5, 6, 7, 8, 9, 10. X is now 11. Because in fact, the way the loop terminates is that x goes out of bounds. It's not enough just to reach 10 because I want this loop to execute while x is 10. So when I print 9, when x is 9, we print 9. We come here, we get to the next, and we say x is now equal to 10. I want to print 10. And so it comes up here and it's checking to see, is x greater than the control, this control ending point. And it's only when it's greater than that it lets you out. And so that's why x actually comes to 11. So that's something that's kind of not intuitive about the loop. You think, oh, it's going to take x up to 10, and then it'll stop, and it comes out. But it actually has moved it past the boundary. That's why it ends. Now, that's not entirely true. It doesn't end because x goes out of bounds. It ends because x goes out of bounds, and we went back to the top of the loop. Watch this. I'm going to make x go out of bounds right here. We're going to come in here, and we're going to say x equals x plus 100, 1,000. That's out of bounds. But I'm going to print x. What's that going to be? First time through, that should print. X starts at 2 here, and I immediately say x takes on a new value. What is it? 2 plus 1,000. So when this prints, it's going to print, 1,002. Holy cow, that's out of bounds. That's way more than 10. X equals x minus 1,000. That'll put it back down to 2. We'll hit the next. It's going to add 1 onto it, make it 3. It'll come up here. Is this 3 larger than 10? Nope. X equals x plus 1,000, 1,003. And it's going to print this. So the point here is that it's not exiting the loop because the variable went out of bounds. It exits because when it got to the top of the loop, it checked. And it said, what's x now? So I can do whatever I want to with x in the middle, and it won't affect the loop until x gets back up to the top. So x has to go out of bounds, but it has to go out of bounds at the moment when I'm inspecting it, and I don't expect it until the top of each time through the loop. How are we doing, folks? Should we actually make this do something? Let's make this do something that's kind of somewhat useful. What if we just made this do a Fibonacci sequence? That's a really good idea. Sold. Let's make it do a Fibonacci sequence. X equals, okay, so I am going to print x. So let's start let's take x from 1 to 50. Oh, did I ever change anything on the step? You can put any number you want to on the step and that'll change it. Debug.print, let's get rid of this x plus 100. Debug.print x. Now x is going to, but we're going to have to get past to the second value back. So in this case, I'm going to need another variable. In case you haven't figured this out yet, what I'm doing is really quite different from the homework that's due tonight, but y as long, print x, and I'm going to have to start off at x equals, we'll say y equals, this is kind of tough, sounds like I need another variable. Dim z as long, z. There we go. Let's say y equals 0, z equals 1. And now I want to print y plus z. And now I got to shift those two variables. Make a third one that I don't even want. I got so many variables here. Turns out you can do this with like one variable in the example. Dim q as, no, shouldn't need to do that. Okay, so we're going to print that, and now we're going to say, we only need the last two. We're going to print that, and so we now need z. Print that. Now we're going to say y equals z. As soon as I say y equals z, I've lost it. This is a lot easier if I'm putting it into, if I have a cell to put it into. But I can't very well do that because that's the homework assignment. So, let's go ahead and do one more variable. X, y, and f for Fibonacci. Dim f as long. F equals y plus z. Debug.print f. And then we're going to say, okay, so now z equals y equals z, and z equals f. Yeah, this is a lot harder than I would want you to have to do. For your homework, you want to think that you're going to say, I'm just going to offset from the active cell, and this gets a lot easier. So, what do we have here? So the first time through, f is going to equal 1. We're going to print 1. We're going to have to start with putting the 0 and the 1 before, but we can do that outside the loop. And then we're going to say y equals z, so y will become 1, z will become 1, and so the next time through, that should do it. Overflow. Oh yeah, that's a problem. So I'm missing the first 2 in the sequence, so I have to print those up here. Debug.print. Debug.print what? Y. Just print 0 and 1, or I'll print y and z. And so, could I specify both of them in the same line? The answer is yes. I'm not sure why you'd want to, but we could. So now I'm getting the 0, 1, 1, 2, 3, 5, 8, 13, 21. Eventually it stops. Why is it stopping? Because long only goes at 2 billion. And the Fibonacci sequence exceeds 2 billion in the first 50 numbers. So what am I going to use instead of long? Double will do it. X could actually stay as a byte. And I'm going to go ahead and print the step number as well. So I'll print x comma f. And there we've got the first 50. Actually, x doesn't need to go to 50. Probably should only go to 40, 48. Because I've got 2 happening outside the loop. Yeah, so I've got these 2 here. X and F. Oh, that's so funny. I'm gonna print it this way. So I'm gonna print 1 comma 2 comma, and then X is gonna go from 3 to 50. I like that better. And that way I should actually see the proper numbers going in there. So there's the first number in the sequence is 0, and 1, 1, 2, 3, 5, 13, 21. That's all I can remember, 21. And eventually it gets up there to 50, which is like, what is that, 700 billion? 7 billion. Okay. People on the video are like, why was that useful? But the folks in the classroom know there's a homework project on this. Okay. So there's a Fibonacci sequence. Yeah, well, except X is a byte because X only has to go up to 50, but the rest of them are double to get big enough to hold it. But I don't know what's easier, copying this or thinking through it just with the offset, but yeah, I probably shouldn't have done that. Oh well. Okay, that's the for loop. I guess one of the things that I do want to show you is that I forgot to mute my phone. It's my son. My mother called me during my morning class. My son called me in my afternoon class. I'll mute the phone. Hope he's not dying in a ditch somewhere. Okay. Oh, so the point is that you can step by a different number. 6. Well, let's leave this as 1, and I'm going to go ahead and make another, like a do loop 2 or something. because there's some other, I want to spend a little more time on that step parameter. Do loop 2. Dim x as integer, or x equals, let's go the other way. No, let's do 1 to 100, step 2. Debug.print x. Okay, so that should print the odd numbers up to 100. 91, 93, 95, 97, great. But what happens if I say I want to go from 100 to 2 or to 1? We'll clear this. Let's see what happens if I don't put any step on this at all. I'm going to run that, run it again. And it's, yeah, that's it. Let me go ahead and print at the end. It's running, it's just not printing anything. Debug.print. Now x is probably would have been better, faster to type that even for me. Now x is 100. How does it happen? It says, great, x is starting off at 100. And we immediately check, is 100 larger than the ending condition? The answer is yes. We're done. It never executes what's inside the loop. Unless I come in here and say step -1. If the step is a negative value, it goes, oh, we're going down. Now I got to go until x is less than the ending number in my sequence. And so now if I run this, it should count down. And we can count down by, 2s or 3s. What's the question? Oh, F55? That's me probably trying to hit F5 and hitting the F5 and the 5 key are right next to each other on my keyboard. So, sausage fingers. X is now -2. Oh yeah, because we're going negative by 3. Again, the point here is that x has to get outside of the range that I've specified for it to terminate the loop. And I think that is everything that we want to show, except there's also an exit. Can you guess? Can you guess? Exit 4. Now this seems kind of strange to put just an exit 4 without an if statement in here, because now it's going to go just one time, right? So it's going to come down here for x equals that to 1, going negative, great, we're going to be 100, print 100, exit 4, oh, we're done. So that should just print 100 and then say now x is 100. Because the exit 4 just says, I'm out of the loop, I'm done. Questions on the for next loop? 2 down, 1 to go. I'm looking at that clock thinking we might get out early today. Don't curse it though, don't curse it. We might get out early. All right, the next loop is hard. So, you might be thinking, how can a loop be hard? This is pretty easy stuff. This next loop is going to, okay, everybody stand up. You're going to stand. You're going to wiggle your butt a little bit. It's going to get the blood pumping because I need your full brain for this next loop. We could sing a primary song. Once there was a snowman. You'd have to go, whatever. Okay, you can be seated. So this next kind of loop is called the for each loop. And it's similar to the for next loop, only way harder. Sub, see how hard it is? Sub for each loop. That'll do. Okay, now, like the for next loop, there's a control variable. Dim, I'm going to call this cell as an object. Oh, I think we first talked about object variables the last time we were together. So this is, we got to remember. So it's pretty new to us and it's pretty abstract. So somebody tell me what a variable is. I had in the last class, I asked someone what an object variable is, and it was like blank stares all around. Okay, so we're starting something a little bit easier. Tell me what a variable is. Who can tell me what a variable is? There's two parts to a variable. What's a variable? Go ahead. Professor Greg Anderson calls it a pocket. That's a metaphor. It's a really bad metaphor. And I'm going to have to go talk to him. Yeah, that's not going to get you where you need to be in this class. Go ahead in the back. A place, okay, so it's a place in memory. That's part of it. It's a location in memory. Well, it has a value because every place in memory's got a value. And a name, that's it. So it's a named place in memory. The reason that's important, and the reason why I'm making the distinction, is because in VBA, there's going to be times where we say, I've got two different names for the same location in memory. And depending on how the code's going, I could say change X, it'll change that location, print Y, and that same location will have changed. So it's really important that you get that it's not that X is a bucket and Y is a bucket, because those could be two different names for the same bucket or the same location in memory. So that's what a variable is. And if we think about what's happening in memory, everything is stored in binary, ones and zeros, on and off, positive and negative, depending on what the medium is. And so everything is stored as a one and zero. So how can it tell the difference between a floating point number and an integer? Because it looks at that location in memory and it's like 0, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1. And yet, sometimes that means something totally different than other times. So in addition to saying it's a location in memory, that location in memory or that variable has let me try it this way. That location in memory, that variable is of a particular type. Yeah. So when we declare a variable, we're going to say, declare x as an integer. And when, or dim x as integer, what did we say? Yeah, here's dim x as integer. When we made x an integer, the interpreter says, oh, it's a variable, it's an integer, we need a couple bytes of memory, and so it asks that for the operating system, and it says, give me some memory. The operating system says, great, here's some memory for you, it's all yours, I won't let anybody else touch it. The interpreter gets that address back, and it says, aha, I've got memory. And I'm going to treat it like an integer, which means when I say x equals 5, it says I got to put a bunch of ones and zeros into this 2 bytes of memory so that when I look at it again, I remember 5. And now if x is a string, and I put into string something like alpha, A-L-P-H-A, it says, great, I got this location in memory, and I got to put a bunch of stuff in here, a bunch of ones and zeros. But because it's a string, when it reads those ones and zeros back, it says, I got all these ones and zeros, but this is a string. And I know the first 4 bytes tells me how long the string is. The next, that tells me how many bytes to look, so I got to read that many bytes. I get to the next byte, and I take those 8 bits, and that's going to be a number between 0 and 255. I'm going to take that number, and I'm going to map that back to the ASCII table and say, aha, that's a capital A. I look at the next 8 bits, and that's a capital P. I look at the next 8 bits, and it maps to a capital H, alpha, spelling out whatever I was putting in there. And so the important part here is that I've got the location in memory. It's a bunch of ones and zeros, but what I do with those ones and zeros totally depends on the type. And we spent a whole day talking about these different data types. We did not talk about the object type. So the object type is a named location in memory, just like the rest of the variables. But what do we actually put in that location in memory? Ones and zeros, but how are those ones and zeros interpreted? What's being stored in that variable? Truth is, I'm not expecting you to remember this. We talked about it last time we were together. I think it was the last time. Anyway, we talked about it not too long ago. We're still pretty close to the beginning of the semester. It couldn't have been that long ago. Does anybody remember? What we store in an object variable is a memory address. It's the location of some other place in memory. It's just a place, it's some other place in memory. Now, what's so important about the other place in memory is there's an object there. So if I think about all these cells I've got in my workbook, well, the truth is not every cell gets loaded into memory because no one has enough memory for that. But all these cells that actually have something in it, each one of those cells is an object in memory. I could look at that and say, here's A2. That cell is in memory somewhere. And wherever it is, everything in memory is at some location. It's at an address in memory. And so if I was to say I want to bind an object variable onto that cell, it would say, great, cell number A2, where is it in memory? It's at some address. I take that address and I put it into the variable, the object variable that I've made just to hold it. Now, when I've got a string variable and I say, hey, give me the value of that variable, it has to go and look at all those ones and zeros and apply all the rules that it knows about how strings are stored to come back up with the string that it shows to me. When I say, give me that object variable, it says, great, I've got the memory here, a bunch of ones and zeros, and it says, oh, that's a memory address. It looks at all those ones and zeros and says, great, I can figure out that memory address. And then it says, what am I actually going to return? I'm going to return whatever's at that memory address. And so it's like a hop. It says, you store the memory address. What are you going to give me? You're going to give me what's at that memory address. Just like the string variable says, I got a bunch of ones and zeros, and to find out what this really means, I've got to go to the ASCII table to translate it. An object variable says, I got a bunch of ones and zeros, it's a memory address. Ah, that's what I'm returning. And what that is an object. And so, let's just look at this briefly before we actually show the loop. So, I'm going to say set cell equal to, I'm going to do my sheet, which is called counties, dot range. I'm going to do C4. That's my most explosive range that I know, C4. And what this does with the keyword set, what this does is it says, okay, I've got this object variable, and here's a reference to an object. I'm not trying to figure out the value or the formula of this or anything. I'm just saying this is an object. At some location in memory, take its address and dump it right here into cell. And so now I'm going to print the value of that by saying debug.print cell.value. When I bind this object variable onto the object and then later ask for what's in that cell, it has to hop over there. It looks at the location in memory, it finds an address, and it goes, aha, that's what I'm going to return. And it returns the reference to that object. I'm then asking for the value property of that object. That should print Baldwin County, Alabama. Deleted the wrong thing. Thank goodness for undo. You won't believe this. You'll have a hard time believing. Maybe you will believe this because you believe everything I say, but when I started using computers, there was no undo. The idea of undo had not been invented yet. You made a mistake, it was like, whoops, start typing again. All right, now I just got to remember how to run this. So we're expecting this to print Baldwin County. Oh, it's county, yeah. Counties is the name on the tab, but the code name is county. And there it prints Baldwin County, Alabama, because this cell is just holding the address of the range that I've identified right here. So far, so good? How many of you look at this going, this doesn't feel too bad, I think I got it? How many of you are going, this is witchcraft? No one? Okay. So now on to the for each loop. The for each loop takes this very seriously. Here's what it does. It says for each cell, cell here isn't a reserved word, cell is my object variable. And I'm going to actually comment out this line here. For each cell in, so I have to have an object variable, and then after the in, I have to give it some collection of objects. And I'm going to do, after all, kind of the simplest one is that a range is a collection of cells. So county dot range, and why don't we do C3 to PO? No, C3 to C20 or something. I don't know. There's a bunch of counties in the column C. Is this pseudocode? This is real code. You can tell because when I leave the line, it didn't turn red. That the interpreter looked at that and goes, "Yep, we got it. I know just what you mean." That's the beginning of the for each loop. I'm going to leave the debug.print in here. And then after that, I'm going to put the end. It's just next. It's just exactly like the for next loop. It ends with the keyword next. And now instead of just printing the cell's value, let me also print the cell's address. Cell.address. Now, what this is going to do is that you saw the statement that I commented out there that says set cell equal to a particular cell. That's the magic of the for each loop, is that it says, I've got this object variable here. It just holds an address of some other object, and it's going to bind this on to the first element of this set. And then it's going to execute. And then it's going to bind that same control variable onto the next element of that set. So this should print C3 and I don't know how to pronounce it, and Antigua County, Alabama. C4, Baldwin County, Alabama. C5, whatever the next county is in Alabama. So let me get rid of Baldwin County up here. And I'm going to run that. Autauga County, Alabama. Baldwin, Barber, Bibb. It's just going through all of these. It seems so strange because I don't ever say to print anything besides cell. How could it print all those different things? And the answer is the control variable gets bound on to a different element in this set with each iteration of the code. Now, how many of you are going, this must be witchcraft because I don't get it? No one? This is really, it took me a long time to understand this loop. I'd look at examples for each loop and I'd go, yeah, I don't get it. I'm moving on. Maybe I didn't have me to teach me. That was the problem. Okay. Let's look at another example. It's not just cells. Let's look at an example in a different context. And so I'm going to take the same thing. Oh, hey, let's do one more thing down here. And that is, it turns out there's lots of different words that I can use besides object. Instead of object, I'm going to use range. Range is just a particular kind of object. And two magical things happen when I dim cell as range instead of dim cell as object. First of all, it is an object variable. But now, the interpreter says, oh, I see. You only want to connect the cell variable up to objects of type range. And if I tried to connect this up to something else, like if I tried to connect this up to the workbook, set cell equal to the active ACTIVE. Oh, you know what? I probably should leave that example in there. Control Z, Control Z. I'm going to copy this. Okay, leave that example there. Set cell equal to the active workbook. It says, hey, it's going to say, listen, you can't do that. The only kind of object that cell is allowed to bind onto is a range object. And I can't have two subprocedures with the same name. So let me change this one to for loop 2. And I get type mismatch because cell is only allowed to bind onto ranges. If this was object, this would work just fine. I'm not doing anything with it, but you can see that I'll be able to bind onto it. Object F5. Magical. F5, there we go. And so that runs just fine. So when it's an object, it can bind, declared as an object variable, it can bind on any kind of object. But if I say range, it's now limited just to type range. And so you think, wow, why would I restrict myself like that? And it's not so much because of the protection you get by not accidentally binding it onto the wrong kind of object. It's because now that the editor, not the interpreter, now that the editor knows what kind of variable it's going to be, if I say cell dot, it goes, oh, it's a range. Let me help you with what you might say next. And it puts up, all your options for methods and properties. And so that's the reason that you might want to think, what kind of variable is it going to be? Let me go and attach, make it that kind. So now I'm going to make another abbreviation for a sheet, SHT, that's abbreviation for sheet, as a worksheet. And so now I'm going to say that's the control variable for each SHT in, it's a worksheet. So let me do a collection of worksheets. This workbook, this workbook. This workbook for each sheet in this workbook dot worksheets. Debug dot print sheet dot name. N-A-M-E. Thank you. Okay, how many worksheets do I have here? I only have 2. That'll be pretty boring, but at least you'll see what happens. You'll see it happen. So it should print one called counties and one called sheet 1. Oh, I gotta abbreviate it the way I did before. SHT. And so it's an object variable. This one's allowed to bind onto worksheets, but I have a different collection of objects here. And so we're binding on to each of those individually. Let me go ahead and add a few more sheets in here. Okay, so what might I want to do to each one of these besides print the name? Well, let me print the name. And then I'm going to delete it. Now, I don't want to delete every workbook or every worksheet in the workbook. I can't, right? It's against the rules to delete all the worksheets. You got to have at least one worksheet in the workbook. So let me leave in here the one that has my county names on it. So I'm going to say if sht.name is different than, and then what's the one I want to save? It's called counties. C-O-U-N-T-I-E-S. Not the code name, because the worksheet.name is the name on the tab. What's the code name? The property is code name. Then delete. Delete the object. I'm calling the delete method of the cell that I'm currently, or of the sheet that I'm currently bound onto with my control variable. This can't be code name. This has to be, well, I could make it code name, but then it would have to be county instead of counties. So now it should print off all the names because I'm printing the name and then I'm deleting it as long as it's not counties. And so you go ahead and run that. Oh yeah, this will be annoying. When you delete a sheet, it asks you, permanently delete this sheet. How about we cancel? I'm glad I don't have 100 of these. Okay, so fortunately, are you sure? Are you sure? Are you sure? Yeah, I'm really sure. Fortunately, you can tell it you're really sure by setting a property of Excel itself. How do you get to the whole Excel object? Application. Application dot display alerts equals false. I'm saying, listen, I know what I'm doing. Quit bugging me about this. And so now I canceled all those, so I didn't delete all my other sheets. I'm now going to run this again, and it should just delete those silently. It didn't delete the counties sheet because I said if it's different, if the name of the sheet I'm currently looking at is different than counties, then delete it. Whew. How are we doing, folks? We're okay? Okay, one last thing to cover, and then we're going to get out of here, maybe a minute or two early. So, and that is that we can do a loop inside of a loop. And so let's just give a quick example of a nested loop. We'll get more experience with this later, but I just want you to see the idea today. So sub-nested, let's call it nested. All right, now, I could use a for each loop and say I want to go across this whole range. But when I've got a for each loop, it says I'm going to do the same thing to all of these. So I'm going to treat all of these objects the same way. Now what I'd like to do is I'd like to say, listen, I want to go through everything in column 1 first, and then, what I want to do is, I want to run down all of these in column 1, and then I want to run down what's in column 2, and then what's in column 3. If I just used a for each loop to go across this and print these off, it would go rows first. It would go the first row, and then it would print everything in the next row, and so forth. So here's what I'm going to do. I'm going to dim R as a long. I'm going to dim C as an integer. So integer can go up to 32,000. There's only 16,000 columns. And so integer works pretty well for columns. And now we'll do a for loop. For x equals 2 to 20, 2 to 10. It's R. I got to just give up on R and go to X, but I'm going to leave it as R because it's going to mean row for us. Next. Now debug.print. I'm going to print R. Actually, I'm going to print that particular cell. So county dot cells row R column 3 dot value. That should be the county names. All right, I'm going to go ahead and run that, and that should just give me the county names. There they are. You know, for those, whatever 2 to 10 is, those 9 different county names. But now I want to print the county names, but I also want to print the FIPS codes, and I want to print the states separately. So I'm going to put this loop inside another loop. I'm going to come up here. For C equals 1 to 3. And I'll put a next at the very end. I'm going to tab that in just so I can see the structure a little bit better. And now, instead of just printing column 3, I'm going to print column C. Okay, so let's think about how this code is going to execute. For C equals 1, this is going to give C a value of 1. Immediately, we hit R equals 2. So the first row that we're going to print is, or the first value we're going to print is row 2, column 1. We're going to hit this next, and what does this next do? It makes R go to 3, and we come back up here. We haven't gone out of bounds yet. And so now we're going to print row 3, column 1. We hit this, R goes to 4. 4 column 1, 5 column 1, 6 column 1, 9 column 1, 10 column 1. Next takes it to 11, and that lets us out of the loop. We hit next, and this does what? Changes C to 2. We come back up here, and now C is 2. We come here. Here's the magical part. What happens now here? What happens to R? R goes back to 2. So now C is 2, R is 2. We increment R. We go row 3, column 2, row 4, column 2, 5, column 2. We eventually hit the next here. That takes C to 3. R gets set back to 2, and we go row 2, column 3, row 3, column 3, row 4, column 3. So this should print off all the FIPS codes. Then it should print off all the states. Then it should print off all the counties. And let's see if that works, and then I'll take your question. FIPS codes, states, counties. Question? This is exactly how you go through a matrix. Absolutely. Yep. Okay. If you're looking at this nested loop and it's making your head hurt, relax. We're going to hit it a couple more times here in class. But I want you to be exposed to it today, and we're done 2 minutes early. Thanks for coming. Class dismissed.